Hello guys, this is Big Data and welcome to Apache Spark tutorial on window functions. In previous video, we covered about how to do joins and group by. In this video, we are going to talk about slightly advanced analysis on our stock pricing project. And that is specifically to do analysis using window functions. So I want to cover two things over here. One is how is window function different than group by function? And how would it be beneficial to use window function to do advanced analytics on the stock pricing data that we have. So to compare the window function and group by function, one of the major difference between two is that in group by function, once you group the data by particular bucket, so for example, if you group the data by ticker or if you group the data by year, then any function that you are going to apply is going to apply to all the observations in that group. So for example, if you group the stock by the ticker, stock price data by the ticker, then what would happen is that when you say I want to calculate average by ticker, then it's going to take all the observation under Microsoft stock, under BRKB stock, under Meta stock, under Google stock, unique stocks, and pretty much going to go and perform average function across a particular column like open. But let's say you don't want to calculate average on such a large window because we have across the years, like we're close to 5 years worth of data, and we do not want to perform group by operation on entire 5 year of data because it does not give us a lot of information about how the stock price is moving, right? So we want to be able to perform operations like, what's the difference between open price of the stock yesterday and the stock today, right? So if the Microsoft opened way lower than today, then I might not want to make a purchase of the stock today. But however, if the Microsoft opened way lower compared to yesterday's open, then I might want to make a purchase, right? Another such operation would be moving averages. I would want to track how is Microsoft stock, averaging over last 15 days, last 50 days, last 200 days. And if the current price of the stock, like let's say last 15 days moving average is less than last 50-day moving average, then we want to be able to make a purchase because we are going, we are getting a good deal on the stock, right? So the point is what window function allows us to do is it allows us to compute some aggregation on slightly smaller group of data. I wouldn't say group, it's more precise to say window of data, right? So let's say in real world example, if you are at a theater and you want to measure height of the 5 people, the immediate 5 people who are in the ticketing queue, then what you're going to do is you're going to take a window of 5 and then calculate the average height and then keep sliding the window over to get the get the height of in the groups of 5 people continuously, right? And then eventually you could figure out that which group has the highest height and maybe you would want to give them tickets for free. I don't know, but this is just an example that if you want to do something like that, then window functions are very helpful, right? So let's get started. So we talked about two things. One thing that we talked about was that we want to be able to calculate the difference between the yesterday's open and today's open, right? And we want to see, after that, we could pretty much apply a UDF to figure out the difference between the two. We are not going to apply UDF today. I'm just going to show you how to do lead and lag in our stock price data, right? So what I want to do is first I want to just say cleaned stock.show. So let me just pick a very old data frame. So we are going way before. We have covered this in second or third tutorial where we process the stock, and this is where we got, right? So we have pass date, we are open, we have ticker, and then a few other information, right? So let's say we do not want to take like all that information. We just want to do analysis on a few columns, right? So we're going to say snapshot and we're going to select a few columns from here. And the columns that we're going to select is ticker. We are going to select past date. All right, so I'm just going to copy paste this. And we want to be able to do operations on open price, right? Now, it's important to make sure that when you only want to process certain columns, don't take the whole data frame. The smaller the data frame it is, the better the performance you're going to get. So if you're not going to require all of the column, try to make sure that you have minimum amount of column when you're performing some sort of computation. Try to select and filter the data in advance in order to do some computational optimization. We're going to cover about optimizations later on, but let's say we create a snapshot data frame, and we are just going to go and look at snapshot data frame and see what we get. So we have about 3 columns in snapshot data set, which is ticker, parse date, and open price of the stock, right? So we want to calculate what's the open price of the stock yesterday, right? So for that, we are going to use window function, and the way that we can do that is all we are going to say is we're going to say from PySpark.sql.window import window. So this is going to help us write window function. And the first thing that we are going to do is we are going to describe how do we want to go and use this thing. So because we want to calculate the lag, so lag 1 day, right? So I'm just going to define a condition, and we're going to say I want to create a window and I want to partition by, right? So partition by is similar to group by, but we are going to, it's pretty much saying that we want to create a window or a particular partition. So partition is going to be ticker in this case, because we want to be able to do group by ticker. But instead of taking all the data after doing a group by, we're going to use partition. So partition by is going to allow us to select smaller subset of the data, right? And what we want to do is we want to order by parse date, right? And the reason why I want to order by parse date, and by default this is in ascending order, is because we want to make sure that when we do the lag of 1, we get only 1 day previous data, not not any random data, right? So that's why we want to order them, and this is going to be a window condition. And then once you write a window condition, we want to be able to utilize this, and the way that we utilize this is using with column, right? Just like how we use the UDF, we are going to do the same thing over here. So we are going to say snapshot dot with column, and then the column name is going to be previous open, right? So this is like 1 day behind previous open. And we had imported all the PySpark function above somewhere. So let's go and look at how did we import them. So if we go on the previous day, let's keep going back up. The way that we imported it was as a func, right? So we are going to use the lag func from there. So a function called lag from the PySpark library. So we're going to say func.lag, and we're going to say that we want to lag the column open by 1. So it's going to lag open by 1. But how do we want to do that? And the way that we want to do that is we want to say over, right? Make sure you don't close the parentheses on the entire operation like I did, because it's going to run into an error. So make sure that you have the correct parentheses closed. So you want to do it over the lag 1 day, right? So this is the window condition that we want to use. So you're saying that I want to perform the lag of 1 and the open column over this window function. And whatever result you get, just store it into the previous open column, right? So let's go and close this, and then I'm just going to show this data frame. So let's go ahead and see what we get, right? So look at this. We got Apple on 2018, 531. This is the farthest our data goes back, and the price of Apple on that day is 46.81, right? And on the 1st of June on 2018, the price of Apple is 47, but we also get the previous day's open is 46.81. So we did get it over here, right? And similarly, the previous open is 47, 47.91, and so on, right? So now you can go ahead and write a UDF function to pretty much calculate the difference between the two, and you can determine whether or not I should go and buy stock on a particular given day, right? So I'm not going to write UDF today on this. This is your assignment. You could go and write it on your own and try it out, like, refresh your knowledge and write a UDF to calculate the difference between the two, percentage difference between the two as additional data point, right? So anyway, so this is one way to do that. Another interesting computation that you might want to do is that you might want to calculate moving averages, right? So you want to say that, can you go and calculate me like, 15-day moving average or 50-day moving average? Because some of these functions, some of the moving averages are very important factor that any analyst would take into consideration when trying to think of making a stock purchase or not, right? So let's go ahead and calculate the moving average. And I'm just going to show you how to calculate a simple 50-day moving average, and then you could use the same function over to go ahead and calculate, moving averages for like less than like 50 days or more than 50 days, whatever you want to do, right? So you just need to modify minor window condition to do that. So let's go ahead and say moving average is the window function that I'm going to write, and to do that, we're just going to say window dot partition by. And again, we are going to go and partition by ticker, right? Because we want to calculate the moving average for a particular stock. So we're going to group, essentially like, group or, partition by ticker. The reason why I'm not saying group by and why it's termed as the partition by in the Spark library itself is that we're not doing a group by operation. We are doing, window operation, right? So it's on a much smaller set of data, and that's why it's a partition by and not group by. Group by contains all the data within a particular group, right? So again, we're going to go and say that we want to order by parse date. So let me go and copy paste the name so I don't misspell it, right? So I'm just going to say parse date. And I want to have rows between. There's a function called rows between. And by the way, if you want to know about this window functions in PySpark, you can go and read the documentation. I'm going to show you how to read documentation in next tutorial. But there are all sorts of different functions like, rows between, range between, row number and whatnot, right? And when you use those functions, you're going to be able to do variety of operations, right? So we're going to look at like few such functions. We already looked at rows between. We are also going to look at row number in the next step. So stay with me. So anyway, so what we want is we want to calculate 50-day moving average, and the way that I'm going to calculate 50-day moving average is I'm going to say that go and get me all the rows between -50 and 0, right? So get me the previous 50 rows and today, right? And interestingly, what it's going to do is that if it has less than 50 days, then, that's where it gets faulty. It's still going to get you like, less than 50 rows. It's not going to get like, it's not something like where you get, where if you have only 50 rows, then only it's going to show up. It's not like that. Even if you have like one single row in that particular window, then it's going to just calculate average using that one row, which is not what we want, by the way. So the idea, and interestingly, what you need to know over here is that this is, the stock price data is not a continuous data, right? Unlike other time series. So stocks only trade on the working days. So you can see that the price of the stock of Apple is on May 31st, and then you have June 1st data, and after that you don't have data for June 2nd and June 3rd because it would be Saturday and Sunday, and then you have data for like 604, 605, and so on. And similarly, you wouldn't have data for like July the 4th because that's a that's a holiday in the US, right? So you won't have the data for that if it was not falling on Saturday and Sunday, right? The stock market is not open on that day. So when we say range 50, what it's going to do is it's going to calculate the previous 50-day open average, not like the exactly 50 days from today. The previous 50 opens is what we are calculating in moving average over here, right? Okay, so let's go ahead and use this window function to calculate the average. And the way that we are going to do that is pretty much going to be the same way. We are just going to say snapshot with column, and then the column that we are going to say is that it's going to be MA50, denoting moving average 50. And then we are going to use Python inbuilt, sorry, not Python, the Spark inbuilt function called average. And the column that we want to take average on is open. And the way that we want to take average over is this particular window called moving averages window. So we're just going to say go and take the averages over this window, and go ahead and show me the results, right? And then when you go ahead and see this, you get this. Now we are losing some precision over here. For some reason, Spark is, because it's, doing a lot of computation, it's not getting good precision. So we want to be able to round this off to 2 digits. And the way that we could do that is, again, we could go ahead and, again, use with column over here and then round that off, right? So let me go ahead and do that. So I'm quickly going to go and, create a chain operation. So I'm just going to copy paste this. And then I'm going to say that I want to, go ahead and let's close out the bracket first. So this time the function that I want to use is called round, and I'm going to be rounding a column called MA50 because that's the column that we created, and then I'm just going to round it to the nearest 2 digit. I'm not going to be using over because we are not performing any window functions anymore, right? So we have closed all the parentheses perfectly, and because the column name that we are using is the same as the column that we are modifying, it's just going to do the in place operation and replace the column that you have over there, right? So let's go ahead and see what we get. So now it's a nice little rounded number that you see over here, right? So it's well and good. And like I said, you see over here, it only has one observation. So it only takes that one observation into consideration when calculating moving average. So it's not like, it has to have 50 observation in order to calculate the moving average, right? So this is one of the drawback that you see over here of using rowsBetween function. So what you'll have to do over here is that you'll just have to specify null if you don't have the data that far back enough. Otherwise, what's just going to happen is you're just going to say, like, let's say if IPO is listed today, you're not going to have last 50 days worth of data, right? So the 50-day moving average, 200-day moving average, everything is going to be what the price of the stock is today. So that's what we are calculating over here by default, right? But as you increase, as the days as the day goes by, more and more, you start getting like, better and better moving, like, averages, because you get more and more rows. And, the price of the stock is not moving that much. So as you can see, as more and more observations are getting into consideration, the price of the stock is not moving that much, right? So by the time you get to 50, you're gonna barely notice the price moving unless there's a large movement in the open price, right? And based on this, you could take decisions, right? So you can calculate moving average 15, 50, 100, and 150, and 200, right? One of the interesting indicator that the analysts often use is the MA50 and MA200. Whenever MA50 goes below the moving average 200, it's a good indicator to buy, right? So anyway, so this is how we calculate moving averages using window function. Now, one last thing that I want to do is I want to be able to calculate maximum open price of stock in like, let's say, over the last 5 years. I just want to see the maximum 5 or 10 open price of the stock in all the data that we have, right? So I want to see, show me the highest 5 opening price for the stock. So how do we do that? So again, we are going to be writing window function in this case as well. So this is like, third application, third example of writing a window function. And the way that we are going to do that is we are just going to say maximum stock. Let's say this is a window condition that we're going to write. We're going to say window dot partition by. And by the way, you could use more than one partition over here. You don't just have to use one single partition like we're using ticker all the time. The way that you could use more than one partition is just use like, the list, and you should be able to do that operation using multiple, columns to perform partition by operation, right? But in this case, we're just going to use ticker because we don't want to find, like, let's say if you want to find the maximum stock price on yearly basis, then we need to introduce one more column called year over here. Like, we also need to say that, get the year, and then use year column as additional data point to go and, get the stock price, the maximum 5 open stock price for a given year, right? So let's just calculate it for the entire data set that we have. Let's say for some reason you want this data and just want to see what's the maximum open stock price. So the way that we're going to do that is that we're going to go and say that I want to be able to go and do the partition by ticker and then order by the snapshot dot open column. But this time you want to order in descending order, right? We don't want to order in ascending order. We want to do it in descending order. And the way that you could do that is by default the order by doesn't this order by the window order by function does not take ascending as an argument for some reason. So we have to do it like this. We have to manually go and select the column and say that descending, and you could do this, right? So what we are saying is that take the snapshot data frame, take the open column, and then use the descend function on top of that to order by in descending order, right? And the reason why we are able to do this is because you're going to be using this window function in this data frame anyway. If you're using a different data frame to perform operation, we're going to get error. But because we are going to be performing the over operation, the window operation on this data frame, you can go and refer the column like this, right? So you can go and say that snapshot dot with column, and then column, and this is a max open, right? And then we are going to be using func, and then we're going to be using row number. So what this row number is going to do is going to pretty much go and give you a row number, right, over maximum stock. So let me go and show you what happens when you apply this function. We just get the descending order prices over here, like you see for Apple, 182, 181, 180, 179, and so on. And you get the row number associated with it, right? Because this data is sorted in the descending order of the open column, you get 1, 2, 3, 5 from the maximum open price to the lowest open price, right? So all we need to do in order to get the top 10 highest prices, I'm going to be doing top 5 instead of top 10, so like we can visualize it for different stocks, is that we are just going to be using this window function. And by the way, what you should be doing is you should be storing the results somewhere in a new data frame, or persisting it for the optimization purpose. Otherwise, what's going to happen is that we're going to calculate this again, right? And in this case, because they're not stored this data frame anywhere, we're going to go and calculate this operation again, right? So let's go ahead and say filter, and our filter condition is going to be max open. That's the column that we are saying, and it's less than or equal to 5 because you want to get the the maximum 5 open prices for the stock. So let's go and execute this, and this is what we get, right? So we get 5 for the Apple, the maximum open prices, right? And it doesn't necessarily have to be in the same year. See, you see, one of them is in 2022 January, and other one is uh, somewhere in the 2021 seventh month, like July 9th, right? uh, for Amazon at least. So there are different duration. They're not like recent. That's what I'm trying to say, right? So that's the point. This is how you can use row number, and there are few other functions that you could use to go and perform a variety of operation. Now, getting the maximum open price is a bit of peculiar way to go and get this operation running, because you would like naturally you would think that I would be using max function in order to perform this operation, right? But instead of using max function, we're using row number function to calculate this operation, right? And it makes sense, right? Because the max is just going to give you the maximum value. It's not going to give you top 5 or top 6 maximum value. That doesn't take that, the function doesn't take that as an argument inside it, right? It only gives you one maximum value. But here we are looking for top 5 maximum values, right? So that's why you're using row number after actually partitioning by ticker and then ordering the open price in descending order, right? So essentially what we are doing is we are getting maximum stock price at the top, and each time we assign a row number, or what we are doing is we are cutting it off at 5 to get the maximum stock price, right? So this is how you can use window function in Spark to perform advanced analytics, and it's very important concept that you as a data engineer should learn, not only in Spark but also in SQL as well, if you want to move from a beginner data engineer to intermediate or advanced data engineer, right? Because it gives you with a very strong toolkit in your armory to perform this sort of operation that otherwise you'd not be able to do um, with group by operation, right? So yeah, that's it for this tutorial. Thank you, and see you in the next tutorial, where you're going to talk about different things, how do you save data using PySpark. And we're also going to talk about how to go and refer documentation. And again, this code can be found in my GitHub link that is going to be attached below this tutorial in the description section. So go and look at it. And please like the video and subscribe. Thank you. Thank you very much. Bye.